Hey everybody, welcome back to Algebra 2 Priority Standard 6. Our learning target today is 6.2.1 on simplifying rational expressions by multiplying, dividing, adding, and subtracting. So today's video is going to focus on just the second part of this learning target where we are going to simplify rational expressions that involve division. So let's get started. As we're getting going here, there are some rules of exponents that you need to remember. You may have seen these in Algebra 1. We've used them a little bit already this year, but make sure that you know all 5 of them. The first one, we have an example a to the 0, and you could really substitute for that any number or variable raised to the power of 0, and the answer is going to be 1. So the rule is anything to the power of 0 is going to equal 1. So you could have a to the 0, if you could have x to the 0, you could have 5 to the power of 0. Anything to the power of 0 equals 1. Our next example here, we have two different exponents being multiplied together. X squared times x to the 7th. And a way that you could visualize that one is if you write the whole thing out. X squared is the same as x times x, and then we're multiplying that by x to the 7th, which is x times itself 2, 3, 4, 5, 6, 7 times. And if we do that all out, now how many x's do we have in total? Well, there are 9 of them now being multiplied together. So this is equal to x to the power of 9. And notice that 9 is 2 plus 7. So when you have two exponents with the same base, these are both x to the power of 2, x to the power of 7, you can combine them by adding the exponents. So when two exponents with the same base are being multiplied, add the exponents. And division works similarly, just in reverse. If I have x to the 8th divided by x to the 5th, so x to the 8th would be x times itself 8 times. 3, 4, 5, 6, 7, 8. And that's divided by x to the 5th, which is x times itself 5 times. Then if I simplify that out, a lot of these x's can cancel. X on top, x on bottom, x on top, x on bottom, canceling and canceling and canceling. And then we are left with 3 x's multiplied together in the numerator. So this is equal to x to the 3rd. When two exponents with the same base are divided, you can subtract the exponents. So we did 8 minus 3 and got x to the 3rd. So when exponents with the same base are divided, you can simplify those by subtracting. Subtract the exponents. Next rule is when we have a power of a power. So b to the 8th to the 5th. So b to the 8th times itself 5 times. When that happens, you can multiply the two exponents together. So 8 times 5 is 40. That would become b to the 40th. So when you have a power of a power, you multiply the exponents together. when you have a power of a power, multiply the exponents. And last thing, what happens when we have a negative exponent? And you may remember this, a negative exponent turns it into a fraction. So if we have c to the power of -8, that becomes 1 over c to the 8th. So it flips to the opposite side of the fraction and now becomes a positive exponent. So for a negative exponent, take the reciprocal, flip it to the other side of the fraction, and then make it positive. So for a negative exponent, take the reciprocal and make it positive. So to sum up these rules that we're going to be using here today, anything to the power of 0 equals 1. If you have two different exponents being multiplied together, then you can add the two powers. For instance, x to the 2nd times x to the 7th becomes x to the 9th. If you are dividing exponents, you subtract the powers. If you have a power of a power, then you can multiply the two exponents together. And if you have a negative exponent, flip it to the opposite side of the fraction and make the exponent positive. So now let's practice using these rules to simplify. And as you're simplifying, we're going to keep in mind PEMDAS, your correct order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. So in these first two examples across the top, we don't have any parentheses or any multiplication. We can go straight to division. And the rule is that when you are dividing, you subtract the exponents. So z to the 8th divided by z to the 5th becomes z to the power of 8 minus 5, which is 3. If we have the second expression here, p to the 3rd divided by p to the 8th, again, the rule is that you would subtract those exponents. So 3 minus 8 becomes -5. And now you also have to apply your rule for a negative exponent. If we have p to the power of -5, we flip that to the opposite side of the fraction. We take the reciprocal 1 over p and make this exponent positive. So your final answer, you never want to have a negative exponent. So if you end up with something like p to the -5, change it into 1 over p to the power of +5. In this third example, we also have some coefficients, so you also want to simplify the whole numbers. 30 divided by 5 is 6, so that 6 will go in the numerator. You could think of it as 6 over 1. And then we also need to simplify q to the 6th divided by q to the 8th. Again, we use the subtraction rule. When you are dividing, you subtract the exponents. 6 minus 8 is -2. So this will become q to the power of -2. And now, since we have that negative exponent, we want to switch this to the bottom of the fraction. That becomes 6 over q to the 2nd. So a common mistake that students will make on problems like this is they will take the whole thing, they will take the 6 and the q and move it all to the bottom of the fraction. Only the part that has the exponent on it gets to switch. So if we have q to the power of -2, only the q moves to the bottom of the fraction. So 6 divided by q squared would be the correct answer. Now let's move on to some that are a little bit more complicated. In this first one, we do have some parentheses to the power of 2. So we need to simplify our parentheses with the exponent before we deal with multiplication and division. The rule is that we have a power of a power, and when that happens, you multiply the exponents together. So we're going to do 2 times 4 and 2 times 7. So that gives us x to the power of 8 and z to the power of 14, all divided by x to the 10th and z to the fourth. Now that we've taken care of our parentheses with the exponent, now we can go to our simplification with the division step. So we've got x to the 8th divided by x to the 10th. Subtracting those leaves us with x to the 8 minus 10, which is negative 2. And for the z terms, we've got 14 minus 4 leaves us with z to the 10th. And again, we don't want to leave it with a negative exponent. So if you have something like x to the power of negative 2, we're going to switch that to the opposite side of the fraction. So the z to the 10th stays where it is. That's a positive exponent. But the x to the power of negative 2 will move to the denominator and become positive. The second example here to the right doesn't have any parentheses, but we do have a fraction that needs to be simplified. The whole numbers are 12 over 3. That becomes 4. And then dealing with the variables, we've got a to the 5th divided by a to the 9th. 5 minus 9 is negative 4. So this will be a to the power of negative 4. And b to the 15th divided by d to the 5th. Those are not like terms. We can't combine the b and the d. So we just leave the b to the 15th where it is, and we leave the d to the 5th where it is. And then you just want to double check if you have any negative exponents, which we do. This term here with a, that's going to switch to the bottom of the fraction. So I'm left with a 4b to the 15th in the numerator, and a to the 4th and d to the 5th in the denominator. Next one here in the bottom left, we have a to the 5th, d to the 7th divided by a to the 3rd d. So taking these one variable at a time, a to the 5th divided by a to the 3rd. 5 minus 3 is 2, so we've got a to the 2nd power. And one thing to remember is that if you don't see an exponent written in, something like just d here in the denominator, that's d to the 1st power. So we've got d to the 7th divided by d to the 1st. Subtracting those gives us d to the 6th. So a squared d to the 6th would be the answer there. And one more. We've got a to the 5th divided by a to the 3rd. Oh, we just did that. Subtracting those, 5 minus 3 gives us a to the 2nd. This time we have d to the 7th divided by d to the 11th. 7 divided by, or 7 minus 11 gives us a power of negative 4. And since we have a negative exponent, we're going to move just that term to the denominator of the fraction. So the a to the 2nd stays where it is in the numerator, and the d variable to the positive 4th power is now in the denominator. So these are all examples of simplifying rational expressions involving exponents. So these are all just expressions that have some variables in the denominator, practicing using our rules of exponents. Now we are going to make it one step more complicated by involving some division. So instead of having just one rational expression with exponents in it, we now have two, and they are being divided by one another. So the important thing to remember is that dividing by a fraction is the same as multiplying by its reciprocal. So a very simple example, dividing by 2 is the same as multiplying by 1/2. Either way, it cuts your quantity down by a factor of 2. Dividing by 1/3 is the same as multiplying by 3. So anytime you're dividing by a fraction, it's the same as multiplying by its reciprocal. So that leads us to the little mnemonic KCF, or keep, change, flip. So if we have two different fractions here being divided by one another, as we do, dividing by this second fraction here is going to have the same effect as multiplying by the reciprocal fraction. So we keep our whole first part of this 14 m to the second n to the fifth p divided by 9m to the fifth n squared p to the seventh. And instead of dividing, we are going to multiply by the reciprocal. So we take the second fraction and turn it on its head. The 3n cubed p to the fifth comes to the top, and the 7m to the 11th goes to the bottom. So that's step one. Keep, change, flip, multiply by the reciprocal. And the reason that we do that is because it's easier to simplify multiplication than it is division. Now, if you think about PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, I don't see any parentheses here, so my next step is multiplication. We are going to multiply across the top and across the bottom. And you'll remember that your rule is when you're multiplying exponents with the same base, you add the powers. So my whole numbers here, I've got 14 and 3. And that's going to give me a whole number of 42. M, I only see once here. So there's nothing that combines with. It just stays as m to the second power. N's, I've got n to the fifth multiplied by n to the third. So since those are being multiplied, we add the exponents. 5 plus 3 becomes n to the 8th power. And then p's, I've got just a single p here, in other words, p to the first, multiplied by p to the fifth. 1 plus 5 gives me p to the 6th power. And then we are going to do the same exact thing, multiplying across the denominator. Whole numbers, I've got 9 times 7, which is 63. M's, I have m to the fifth and m to the 11th. So multiplying those together, adding the exponents, 11 plus 5 becomes 16. So m to the 16th power. And then there's only one term with n and only one term with p. N squared and p to the 7th stay as they are. So that is step 2 and step 3. We have multiplied across the top. We have multiplied across the bottom. Now that we're done with multiplication, we can deal with our division, the next step in your order of operations to simplify the fraction as a whole. So again, we'll take this one step at a time, starting with my whole numbers. 42 and 63 are both divisible by 7. And if I divide them both by 7, I am left with a simplified fraction of 6 over 9. That simplifies even further because those are both also divisible by 3. 6 over 9 becomes 2/3. So that simplifies all the way down to 2 over 3. Now I've got the variable m. M to the second divided by m to the 16th. When you are dividing, you subtract the exponents. So 2 minus 16, which is negative 14. Then for the n's, we've got n to the 8th divided by n to the second. 8 minus 2 leaves me with n to the 6th power. And for the p's, we've got p to the 6th divided by p to the 7th. 6 minus 7 leaves me with negative 1. And then your final step in simplifying the fraction is to flip around any negative exponents. So the m and the p are both going to go to the bottom of the fraction. So on the top we keep the 2 and we keep the n to the 6th. On the bottom we keep the 3, and now we also bring down the m to the 14th and the p to the 1st. So your final answer from simplifying this whole expression is 2n to the 6th divided by 3m to the 14th p. One more example here that we will do all together. 7r to the 5th s to the 6th divided by 6s to the 5th t to the 8th. All of that divided by this second fraction. So step 1 is to remember that division is the same as multiplying by the reciprocal. So we're going to keep, change, flip. We're going to keep the 7r to the 5th, s to the 6th, over 6s to the 5th, t to the 8th, change to multiplication, and multiply by the reciprocal of this fraction. So the reciprocal, the 12r to the 6th s comes up top, and the 14r squared t to the 9th goes on bottom. So that's step 1, keep, change, flip. Now we have a multiplication problem to deal with instead of a division problem. So that makes life a little bit easier. Step 2 is to simplify by multiplying across the top and then across the bottom. So as I go across the top here, the first thing I see are the whole numbers, which are 7 times 12. So that gives me 84. I see r to the 5th times r to the 6th. So since we are multiplying, we add those together and get r to the power of 11. And I see s to the 6th times s to the 1st. Again, we are multiplying, so you add those exponents together and get s to the 7th. And then we do the same thing across the denominator. Whole numbers, I see 6 times 14, which is 84. Variables, I see an s and nothing else to combine it with. So we just leave that s to the 5th as it is. T's, I see t to the 8th multiplied by t to the 9th. 8 plus 9 is 17. So this will be t to the power of 17. I already took care of my whole number, and I also have this r squared term that doesn't combine with anything else, but we need to not forget about it. So that's step 2 and step 3. We multiplied across the top, we multiplied across the bottom, we added all the exponents. Now we need to do step 4, simplifying the fraction. So this is where the division comes in. So 84 divided by 84 is just 1. Those two whole numbers cancel each other out. Then in terms of the variables, I see r to the 11th divided by r to the 2nd. 11 minus 2 leaves me with r to the 9th power. S's, I have s to the 7th divided by s to the 5th. 7 minus 5 leaves me with s to the power of 2. And this t to the 17th doesn't have anything to combine with, so it stays right where it is in the denominator. And now I have nothing with a negative exponent. 9, 2, and 17 are all positive, so that is my final answer. R to the 9th, s to the 2nd, divided by t to the 17th. So we have 2 more practice problems here, simplifying these expressions involving division. So go ahead and pause the video. See if you can figure them out on your own. And then I'll give the final answer and walk through how I got my solutions. And here are your solutions for these last 2 problems in box 4. For problem 3, I got the answer 3a to the 8th, b to the 3rd times c to the 12th. And for problem 4, I got e to the 5th, f to the 10th over 4g to the 11th. So if you got those same 2 answers, then you are ready to go get started on some homework. If not, stick around for my answer explanations. So our first step is always to keep, change, and flip. So here I kept the whole first term exactly the same as it was in the given problem, but I changed from division to multiplication and then took the reciprocal of this second fraction. So this got completely turned on its head. The a to the 5th, c to the 5th went to the top. The 20, a to the 2nd, b to the 3rd went to the bottom. Then we combine across using multiplication. So the whole number is 60, and then because we're multiplying, we are adding the exponents together. So here the powers of a are 6 and 5, add up to 11. The powers of b, we just have b to the 7th, so that stays as is. And for the powers of c, we have 8 and 5, Add those together and we get c to the 13th. In the denominator, the only whole number was the 20, so we brought that to the front as a coefficient. Powers of a, we had a to the first and a to the second. 1 plus 2 gives us a to the third. Powers of b, we had b to the first and b to the third. 1 plus 3, b to the fourth. And powers of c, we just had this 1c to the first power. Then step 4 is to simplify the fraction as a whole. So 60 over 20, 60 divided by 20 becomes just 3. And then for each of the exponents, since we are now dividing, we subtract. So we do 11 minus 3, leaves me with a to the power of 8. For the b's, I've got 7 minus 4, which leaves me with b to the third power. And for the c's, we've got 13 minus 1, leaves me with c to the 12th power. And since all of those exponents are positive, we are done. The answer is 3, a to the 8th, b to the 3rd, c to the 11th. For the second problem, we follow the exact same set of steps. So we start off by keeping, changing, and flipping. So we keep the first term exactly the same as it was in the given problem. So those two should match exactly. Then we change from division to multiplication. And then I took the reciprocal, I flipped the second term here. So the 15e squared f to the 6th came to the top. The 20e to the third, g to the second went to the bottom. Now when I combine, I am going to multiply across first. So going across the top, I have whole numbers 10 times 15. That gives me 150. And now because I'm multiplying, I'm going to be adding the exponents. For e, we've got 6 and 2, so that gives me e to the power of 8. For f, I've got 7 and 6. That gives me f to the power of 13. And then we do the same thing across the denominator. Whole numbers are 30 times 20, which is 600. I only have e to the third power, nothing to combine that with, so it stays as e to the third. F to the third, same deal, nothing to combine there. And if you wanted to write those in the other order, f to the third times e to the third, you could. I just like to put them in alphabetical order. But for the g's, we've got a 9th power and a 2nd power. 9 plus 2 gives me g to the 11th. And now I simplify my fractions. 150 divided by 600. First we want to simplify that. That's the same as 15 divided by 60. Those are both divisible by 15. 15 over 60 is the same as 1/4. So I simplify that fraction. 15 over 60 is just 1 over 4. Then for the variables, I've got 8 minus 3, leaves me with e to the 5th power. For the f's, I've got 13 minus 3, leaves me with f to the 10th. And this g to the 11th in the denominator doesn't have any other g's to combine with, so g to the 11th stays in the denominator. So I've got 1 e to the 5th, f to the 10th, or simply e to the 5th, f to the 10th, divided by 4g to the 11th as my final answer. So that's it for the second part of Learning Target 6.2.1, simplifying rational expressions involving division.